Hello guys, let's look at tips on understanding pseudocodes and flowcharts. So we shall start by defining a pseudocode. Remember, this is in Form 3 and also tested in KCSE Computer Studies Paper 1, 15 marks, that is in Section B, and it's compulsory. So tips on understanding pseudocodes and flowcharts. What is a pseudocode to start with? A pseudocode is a way to describe how a computer program works using simple, plain language. It is not real code, but it looks similar to it. Pseudocode helps people understand the steps of a program without worrying about exact programming language rules. So here we just use English-like sentences. So key points. It uses simple English, show the step of a program, easy to read and understand, and also helps plan the actual code. We have an example here. Like for example, we are getting two numbers, add them and give the results. So you can see the pseudocode. We start by the word start, then get the first number, get the second number, add the two numbers, show the results. You see, that is a pseudocode. So pseudocode is simple English-like sentences or statements written to describe how a program works. And for other people or other guys will say algorithm. And when you hear the word algorithm, it just means steps forward in solving a problem. And pseudocode is one of the examples of algorithms. Later on, we shall look at flowcharts. We have guidelines or steps, actually the blueprints, the guidelines for designing a pseudocode. Number one, it must have a title. For example, in our previous page here, you would have given the simple program here a title, a program to add two numbers. That is a title. Then you define the purpose, explain what the pseudocode is supposed to do. So to start with, we write the name of your algorithm or program, that is the pseudocode. Like I have given an example in the previous slide. Then define the purpose, explain what the pseudocode is supposed to do. Number three, use simple language. Write in plain English, use common words. Then number four, use indentation. Indent lines to show hierarchy, what is inside what. So hierarchy here means show what inside what. The common words used in pseudocode or included, we use the word start. A pseudocode must start with the word start and end with stop or end. That is, you can also use begin, end, or stop and start. Then you must use sometimes you may use the word if, then else, while, for, print. Later on in other slides, you'll understand what I'm talking about. So number six, you define variables. Clearly state what variables you use and their purpose. Variables are memory locations. Like for example, you can say x equals to 5. So enter x. Then somebody else says 5. 5 is stored in x. Enter y, 9. 9 is stored in y. So a variable is a memory location that can contain or hold a value. Number 7, we have step-by-step instructions. Break the task into small, clear steps. Then number 8, use loops for repetition. Use for or while loop to repeat actions. Later on in other slides, you'll understand what I'm talking about. Use conditional for decision. Also that one I'll explain later. And end clearly. You must use the word end or stop at the end of your pseudocode. Example of a pseudocode. We have title here. Find the sum of two numbers. Then we are now writing the pseudocode. Remember, we have the rules. You must start with the word start and end with the word end or stop. So here, our example for pseudocode is that we have the title, find the sum of two numbers. So start, define the variables. We have number 1, number 2, and the sum. So here I am defining what my values will be doing, or my variables. So we have num1 equals the first number, 2 equals to second number. Then the sum is now the first number plus the second number. So we input. What are we inputting? We use the word get or input. So get number from the user, that is number 1. Then you get number 2 from the user. Which calculation will be done? Sum equals to number 1 plus number 2. What will be the output? It is the sum. So output the results, print the sum. Then describe the process of checking if a number is even or odd. Now this is a different now pseudocode. You can still see I will start with the word start and end with end. But here we have defined the variables. What are we defining? Number. What are we inputting? Number. So the number will be equals to enter a number. Then you check the condition. Remember our description there, or our question or our problem is describe the process of checking if a number is even or odd number. So we have a condition. If number is equals to 2 or that is equivalent to 2, then print even. Or if number, that is if numbers division, when you divide the number, if it is divisible by 2, you write even. If it's not, that is else, you print odd. So examples of, we have examples of loop and condition. Loop means repetition or repeating itself. So title, check if a number is even or odd. This is whatever I had print screen there. So this is what happens. I have just enlarged that one. Now there is something very important called control structures. Just like when you are milking a cow or you are vaccinating an animal, that animal must be locked somewhere to tame it so that it cannot be wild. That is a control structure. So in computer, a control structure is the way to control the flow or order of actions in a program. In other books, they say they are a set of statements that determine or control how a program runs. So we cannot understand pseudocode and flowcharts if you don't include the concept known as control structures. So a control structure is a way to control the flow or order of actions in a program. It helps decide what the program should do next based on certain conditions. So we have types of control structures. Number 1, we have sequence, we have selection and repetition. Repetition is also called iteration or looping. So sequence means action happen one after the other. If you want to go to C, you must start with A, B, C. That means there is no way you will access C without passing through A and B. Selection means that you are choosing different actions. You are choosing different actions. For example, somebody may tell you to qualify to go to the next class, you must get 50% in mathematics and above. That means it is either below 50 or above 50. So you are choosing, you are selecting. Then repetition, this is repeating actions. For example, you want to withdraw money from an ATM and you are 50 of you. The ATM will ask for the for the PIN. Then once you enter your PIN, you go on with your transaction. Then it will tell you goodbye. Then another person comes. It says welcome. She or he inserts his ATM card, puts the PIN like that. You see now the process is repeating. That is repetition. Example. We have now the sequence. The sequence, for example, here we have a condition, get number, add 2 to the number, show the results. So if the number was 2, it becomes 4. The answer 4 is added 2, it becomes 8. That is now sequence. Whereas selection, if number is even, print even, else print odd. You see now here we have 2 conditions. That's why you're using if. And when you use if, you must use then and then else. We shall see that one later on. Then repetition here, or iteration, or loop. You see we are using for and while loop. So while number is less than 10, add 1. You see now it's determining the condition, it's running the statement, then add something to the condition. For loop, for each item in a list, print the item. So for example, you want to print numbers that are even between 0 to 10. So if number is even, you print. If it's not, you don't print. That is for the for loop. Then let's now go to our giant in the house, flowcharts. A flowchart is a diagram that shows the steps of processing using shapes and arrows. It helps people understand how a process works from start to finish. Now, we have two sisters here. We have the pseudocode, which are English-like statements describing how to solve a problem. Now, once you write the English-like statements, you then draw a diagram describing the statements. That diagram is called a flowchart. For you to draw a flowchart, there are symbols. They are the legitimate, the legal symbols used in drawing a program flowchart. The first one is ellipse or oval. Oval represents the start or end of a process. For example, we have start and stop, or start and end. Then we have a rectangle or a process. It represents step or action in the process, like a calculation. When you want to calculate or to show there is a process, like set pi to 3.14, you use a rectangle. Then we have a decision. A decision, we use a diamond or a robust or a kite, the way you would like to call it. So represents a decision point where the process can branch based on yes or no, or true or false. Example, is number even? True, print the even. No, print the odd number. So here, these are the symbols used in drawing a flowchart. We have a parallelogram. A parallelogram is used for input and output. It is used to show input is getting in or output is being given out. Then we have an arrow, simply shows direction. Then we have a page connector or a small circle. This one shows the next page. Just like somebody tells you, PTO, please turn over. Now, let's look at the guidelines of drawing a flowchart. So, number one, you define the process. Know what the flowchart will describe or solve. Identify the steps. List all the steps in the process from start to end. Then choose symbols wisely. Just like I have described in my previous session, there are symbols like oval. You should not use a rectangle where oval should be used. You should not use a diamond where a rectangle should be used. You should not use a parallelogram where an oval should be used. Then arrange the steps. Place the steps in logical order from top to bottom or left to right. Use arrows. Connect steps with arrows to show the flow of the process. Keep it simple. Use clear, concise, label for each step. Avoid clutter. Keep the flowchart easy to read. Then check logic. Ensure the flowchart accurately represents the process. Verify that all decision branches are covered. Then review and revise. Test the flowchart with real data or scenarios. Revise if necessary for accuracy and clarity. Then example steps for drawing a flowchart. Now look at this one. Start or oval indicate the beginning of the process. Then you have the process or rectangle. Describe each action or step. Decision or the diamond. Show decision points with yes or no or true or false outcomes. Input stroke output parallelogram indicate where data is received or displayed. Then you end with an oval. So here I want us to look at as an example of flowchart. You want to determine whether a number input in the system is even or even or odd. So this is how you draw the flowchart. You start here, then get number, then you see now I'm showing you the symbols used here. Start, then the parallelogram, get number, then robust or diamond is number even. If yes, print even, end. If no, print odd, end. Now this is the flowchart now drawn for you here. So we usually start with the ellipse, start. You see start and stop. I'm using the ovals. Then getting a number, you use a parallelogram, get the number. Then the decision is made here in the kite or in the diamond. Is number even? Yes. Here, this is yes, just like it is here on this diagram. Yes, even. Then if it's not yes, then it is no, then it's odd, and then stop. So this is a simple program showing how those symbols are used. So this is the start symbol, this is the input symbol, decision symbol, output symbol, end symbol. And then that is a small or just a simple flowchart. Let's go complicating issues. Draw a flowchart that for a program used to prompt the user to enter two numbers. The program should find the sum and average, then display the output. The output here is average and sum. So let's look at the pseudocode vis-a-vis or versus the program flowchart. So the pseudocode here starts with the keyword start I have borrowed, then input x, y, those are the two numbers, can be qp or any other might be. Sum equals to x plus y, then the average is sum divided by 2 because there are two numbers, output, average, and sum. So this is just a simple plain text explanation on what this program should do. But when now it comes to the diagrammatic representation, using the symbols I have taken you through above, you start with an oval, start. Then input, we use a parallelogram. You are inputting y and x. Then there is an arrow to flow. Then we go to the process. Process, we use rectangle. Sum equals to x plus y. Then the average is divided by 2. Sum divided by 2. So here we have the print. We are printing, that is print, sum and average, then stop. Then we can go to a more complex flowchart and pseudocode. Here, Askari Society pays 5% interest on shares exceeding 10,000, 3% on shares that do not meet this target, that is shares less than 10K. However, no interest is paid on deposits in the member's bank account. Design a pseudocode for a program that would prompt the user for shares and deposit of a particular member. B, calculate the interest and total savings. C, display the interest and total savings on the screen for a particular member. So basically, guys, here you start by showing the pseudocode where it starts, input name, share and deposit, just like up there. Then it makes a decision. You have decision. If share is the shares greater than 10K, then interest equals to 0.05. You turn this into decimals, into fractions, sorry, times shares. Else, interest is the percentage shares. Then and if. Then if total, then you calculate the total savings, here, should be total savings equals to deposit plus interest plus shares. Then you print the name, total savings, and interest. This is the English, the plain text description of what is happening here. This is a selection control structure for that matter. It is using if, then, else. Then there is this point, and that's the flowchart. You start by drawing the oval, direction, then the parallelogram, enter name, shares, and deposit. Then the decision is made. Is shares greater than 10K? Yes. Then it is 0.5 times shares. Else, if no, it is interest, that is 0.03 times shares. Then you add them together and print them. See, now this is a complex flowchart. We also go for and check on looping, iteration, or repetition. Now, assume whereby you have various students of various classes and the grading system is as given: 80 to 100A, 70 to 79B, etc. up to below 50E. Now, you want to calculate the average marks of these guys. There are several students with several subjects. So write a program that will allow the input of name of the student, marks obtained in 5 subjects: Maths, English, Kiswahili, Computer, and Biology. The program should calculate the total and average marks for each student and assign the grades depending on the average marks obtained as follows. The program should then display each student's name, total marks, and average grade. So let's look at the pseudocode for that. So here we introduce the term repeat, showing there is a looping. So repeat, print, enter name and subject marks, input name, maths, English, Swahili, computer, biology. Then what is the sum? The sum is the addition of the 5 subjects. So the sum is addition of the subjects. You will put all the subjects there. Then average is the sum divided by 5. Then a decision is made. If average is greater than or equal to 80 and below 100, then A. If average is greater or equal to 70 and rest or equal to 79, then B. The story continues all the way until whereby we have grade E. Remember, you must count the number of ifs. If there are 5, you put in 5 and if. Each and every if must be terminated with the keyword and if. Then, and if you use the term repeat, you must use the word until, repeat until. That one you can run more in your textbooks. Then from there you draw now the flowchart, enter the name, maths, English, Swahili, computer, biology. Then once you are clear and keen and correct on the pseudocode, you automatically score in the flowchart. So sum equals to math plus English plus Swahili plus computer plus biology. Average is sum divided by 5. Then you start at the points between 80 and 100. Yes, print, you process grade A. If no, then the system checks for the rest. So here we can just make a few corrections on this flowchart here. So here we can just make sure that this one is correct. So what is really happening here in this flowchart? We will check whether you will check whether this one here we shall have this. Then we shall have the next one that is copy paste. So we shall have another one, then also another one here, and also another one there. So basically what is happening here, the system will check here whether it is between 80 and 100. Then for the second one here, you can just correct that one. It should be, according to the system, should be 70 to 79. Then this one should be 60 to 69. Yeah, to 69. And then shall have that following each other like this. Then you shall have this one. This one is now that is the 50 to 59. So here you need to use this arrow here going to each other. You see now how I'm accomplishing that. So we shall have this one like that. Then you can also have this one here. You shall have the other one is now, this one is for below, that is below 50 there. So here what you usually do, we connect like that. Then any condition going down here, any condition going down here is true. So we shall have our text box here. This is yes. We shall have our yes here. Then we shall also have our no on the other point here. So this is no. So basically what's happening here, if this condition is not met, then it goes to the next condition. If this condition is not met, it goes to the next condition like that. So that is how the point goes. And when we reach a certain point, we repeat. If one student's marks have been computed, then we repeat for the next student. So basically, this is also a good example of what was happening there. So if average here If average is between 100 and thus, you print A. If average is between 70 and 79, B, like that, and then you repeat. You can see now here, once it prints for one student, then it repeats for the second student. So guys, that is the way to pass flowcharts. I have tried to simplify the flowchart for you, especially for a beginner or for students, the students that have just joined Form 3 and tackling this subtopic. Guys, thank you very much for watching. Remember to subscribe. You can also WhatsApp for any concern and for materials in case you need them to be sent for you. Thank you very much.